Hey everybody, Operation Smithy here, and welcome back to another installment of 51 Easy. Today we're going to be going from another ball exercise to a flour sack exercise, and we're going to kind of transition into that, combine different exercises and make it more concise that way. So let's get started. The point of this tutorial is to get more familiar with the iterative process of freehand animation while pointing out a few tricks along the way, and elaborating on some concepts mentioned in the previous video as well. This pertains to our lightweight objects theme, though I'm sure flour sacks are relatively heavy. As you can see, I started out by penciling in the ball and the main frames. Like we covered in the last video, it's best to start the animation off with the main frames before getting into the in-betweens. That way you know exactly where the object is going to be once you get the object in motion. So what you pencil in does not have to be final if you don't want to be. So once we're done penciling this ball in, we can actually move into more of the sack shape while still keeping the fluidity of the original ball animation. The reason we're doing this is because the ball and the flour sack are very similar in shape, and they are also very similar in logic, which we'll get into later. Anyways, as you can see now, I'm starting to get into the in-between, so I guess we can talk more about those as well. As we covered in the last tutorial, easing suggests the weight of the objects. Notice how whenever the ball hits the air, it tends to slow down. If the ball were perhaps heavier, this would have been no easing at all, or it wouldn't have even reached the same height. There are really three things that will affect the weight of your animated object. One is the proximity of the in-betweens, 2 is the frame count, and 3 is the shape of the object itself. So the proximity of the in-betweens basically means the distance of the object in between frames. The distance of objects in between frames impacts how fast your object is moved. So the farther proximity they are from each other, the faster the motion is. But the shorter proximity results in slower motion. When talking about frame count, I'm mainly talking about how long does it take for one event to finish. For instance, when the ball first drops in, it takes about 3 or 4 frames, including when it hits the ground, to actually complete that small little event. And then, when it hits the ground and goes back up into the air, that's its own little event. And then when it rolls, rolls back onto the ground and finishes, that's its own little event as well. In animation, you're going to be breaking up your animation in different ways that you might not have even thought of at first. So yeah, we talked about events. This small number of frames makes the action shorter and more impactful. If I did this in 6 or so frames, the motion would be smooth, sure, but the impact that the object makes or could be making does suffer. It's good to keep these actions visual, but just enough that it gets the idea across, while again, making sure that the impact does not suffer. And then finally, we're going to talk about the shape of the object itself. As I said in the previous video, the shape of the object should change according to the logic of the object. What do I mean by logic exactly? Well, according to Google, logic is basically reasoning conducted or assessed according to strict principles of validity. So this is exactly why animation is so difficult. Every object in animation that has any sort of event happen to it must apply to a set of rules that the shape must move in accordance to. Which is why I decided to cover flour sack for this series of videos. A flour sack is relatively light. The weight shifts to compensate for impact. In other words, weight shifting impacts this shape. It eases in the air longer, which means the more it eases, the less weight the object has. The less weight the object has, the less gravity is actually making an influence on the object. So if we were covering a brick, for example, that is very gravity influenced, which means it's a very heavy object, which means it's going to take less frames to show it falling, and other events like that. So it's a very good thing to keep in mind. Even cartoonish physics and violence reflects what we see in reality. The goal is not to perfectly replicate reality. The goal is to convey any idea of any reality, really. And that's pretty much what it all comes down to at the end of the day. I hope you all enjoyed this video. Please leave a like and subscribe if you want to see more like it. More vlogs coming soon, more episodes coming soon. See you in the next one.